Hello students, this is an example of the binomial probability distribution. In this question, the question says if a seed is planted, it has 80% chance of growing into a healthy plant. So we have the probability of success, P is equal to 80%. And then the question asks, if 6 seeds are planted, what is the probability that exactly 3 do not grow? So because we have here the probability of growing 80%, you have two ways of answering this specific question. The first question is to determine the probability of failure, since we want to find the probability that exactly 3 do not grow. So the probability of failure will be 100% minus 80%, which is 20%. And then we build our table based on that and answer this question. Or we could say since 6 seeds are planted, the probability of 3 of them not growing is the same as saying that the other 3 will grow. So in reality, if this number was different, then the probabilities will be different. But because the 3 here happens to be exactly half of the amount we have here, the probability of success is the same as the probability of failure. So let's do that. I have X and I have P of X. This is the first step we do whenever we want to find the binomial distribution or the probability for a binomial distribution. So here I have 6 seeds. So it could be like 0 will grow, 1 will grow, 2 or 3 or 4 or 5 or 6 will grow. Now I want to find the probability, so I'm just going to use the binomial distribution because this is the binomial. And then click on the 0, comma. The number of trials is 6 because I have 6 seeds. The probability, I am going to use the probability of failure here because the question specifically asks about what is the probability that exactly 3 do not grow. So the probability of failure is 1 minus 0.80, comma, false. We're going to always use false for the binomial distribution because we don't want to accumulate. And then I'm going to populate this. Now notice that the probability that exactly 3 do not grow is this number right here. So I'm going to copy it and paste it. But notice what's going to happen when I build the table based on the probability of success. Okay, now I'm going to use the probability of success, which is 80%. So again, click on the 0, comma, the number of trials is 6, comma, the probability 0.80, comma, false. And then I'm going to populate. All right. Now see here, this is success. And this is failure. So in this case, the probability of success is the same as the probability of failure because saying that 3 will not grow is the same as saying 3 grows out of the 6 seeds that we have. Notice that the probability of success, which is 2 seeds growing, this number, is going to be similar to the complement, which is 4 do not grow. So if 2 seeds grow, if 2 seeds do not grow, oh, it's the other way around. This is actually failure and this is success. So this is failure and this is success. So if 2 seeds grow, that means 4 will not grow. And that's why these are the same. Those two probabilities are the same. And etc. So if 1 seed grows, that means 5 seeds are not going to grow. And that's why this probability is the same as this probability. So you can see here how you can use these interchangeably, and that depends on how you understand the question. So it just happens for this specific question for the numbers to be 3, which is exactly half of this. So saying that 3 will not grow is the same as saying 3 will grow, and that's why those two numbers are the same. So hopefully this video helped you understand how to answer that specific question, and I'll see you in a different one.